I'm presenting my unmanned aircraft test site suitability map. So this is the results of my efforts over a period of a quarter at UCSB, studying in the geography department. And this is kind of like my, you could maybe call it a thesis. I wanted to get back to GIS, and I really hadn't been doing much GIS lately. And this is something I put together here, looking at um, where are suitable sites for picking 6 test sites for the testing and integration of unmanned aircraft systems, i.e. drones, in the National Airspace System. So I'm not going to get into too much detail about it. I encourage anybody to do their own research on this, but this is going to give you some information. So basically, here are some of my data sources. There's a lot of information from the FAA, the Federal Aviation Administration, that you can find. The Electronic Frontier Foundation has been very helpful in providing a lot of public data using the Freedom of Information Act, which I really do appreciate their efforts. I'm concerned about privacy myself, but I'm also a proponent of using UAS, especially for environmental monitoring and for search and rescue. So the United States Air Force has also provided some good data, perhaps to their detriment, but it has been useful for public, especially for myself, to cross-reference with a lot of other data. The Radio Technical Commission for Aeronautics. This is something that most people have never heard of, but a lot of what goes on with the integration and the technical standards of unmanned aircraft systems hinges on the people who work at the RTCA and the people who are working with them in concert to make the proper changes and set the standards that need to occur so that UAS can function safely. So also the Oak Ridge National Laboratory is where I got a thing called a land scan, which is interesting population data. It's not based off of administrative boundaries. A lot of times in GIS we take data from the census data and it's organized by administrative boundaries like states and counties. But this is actually interpolating population by looking at remote sensing data and other information that is put together to actually come up with a raster of population. So you can kind of see here part of this raster. I've actually reclassified it and given it a weight. So this map in general is my creation. It is an art. This is not exact science. It is my way of communicating the complexity of what it takes to integrate unmanned aircraft systems and how we might do it safely. So there is some inaccuracies with this data, and I warn anybody who's looking at this not to take it too seriously, but it is a portal for understanding the complexity. I am not a complete expert. I don't work for the FAA or the government. So as a GIS analyst and somebody who is interested in this subject, I have invested a lot of time and energy in collecting this data and trying to analyze it. So I haven't been paid to do this. And basically, my warning is that there is some error here as far as the location of places. One of the most important things, data that I have collected directly through Google Earth, is the location of manufacturers. So I came up with this idea of trying to interpolate, perhaps to infer how much participation might be involved with testing, and interpolating spatially how close manufacturing capacities are to ideal locations, meaning that it is ideal to locate test sites close to where there are manufacturers and people in the aerospace industry who want to get involved. One last thing, the other last piece of data here that's really important comes from Lynn Alley. I hope I am crediting the right person. This person created all of these polygons that you see for airspace. So we're in Google Earth now, and I was able to take this data as a KML or KMZ file, and you have all this data that is pertinent to aviators, and a lot of it is not so important to me. So part of the complexity of looking at airspace is how do you reduce this down to something that is useful? So I got rid of anything that I felt like didn't represent the majority of airspace, and problem is separating the ideal airspace where you could do testing and separating that from where there is a lot of commercial and civil air traffic. So one way of doing that is looking at restricted airspace and Class B airspace. So if we get rid of this Class C, D, this SFRA, this, oh wait, not restricted, this is a parachute jump, the PGA, prohibited, MOA, a lot of that's related to military or presidential, alert, we get rid of that. And what we have left is restricted and Class B. So what is Class B? Class B is the majority of space that would be associated with an aerodrome around a large international airport in the United States. So when you back up for a second here, you see that, and you start to see some spatial relationships here. You see where there are a lot of these aerodromes, you also see manufacturers. And a lot of these, most of these are all large defense and aerospace contractors. I'll show those to you in a moment. The list that I collected, it's quite exhaustive. So, and I coded the restricted and Class B airspaces with colors that represent what I believe communicates ideal locations. So green is more ideal and red is not ideal, because obviously you don't want to be testing where there's a lot of commercial traffic. So red means danger and green means good. And if you don't know where this is at, this is California, and this is the Mojave Desert out here, China Lake specifically. You can see that there's Raytheon, Lockheed, General Atomics, and this is the Naval Air Weapons Station, China Lake. So this is one of the places that is being proposed for a test site, for example. And like I say, there's a lot of inaccuracies in how I've put together all of this space. I basically just aggregated all of this, a lot of separate pieces of restricted airspace that are at different elevations. To communicate the complexity of this problem, you really have to reduce it down to the principal components. So, like I say, it's an art, it is not a science. This is my way of using GIS technology and saying that I'm breaking this problem down into two simple components here, and one of them is Class B airspace, which is where there's a lot of traffic, which is dangerous, and here, which is restricted airspace, which is commonly used for testing of airspace in defense, and where there's also live fire ranges. So it's a very simple way, easy way of looking at this problem. It's not perfect, but it helps to communicate in a simple way the complexity. Some of the data that was collected from the Electronic Frontier Foundation I used here. These are public UAS stakeholders. So that's what the P represents, public, like police and city. These are people that have either applied for a certificate of authorization to the FAA to fly drones. Maybe not all of them were approved, but as stakeholders, they are people that either have been given approval or have asked for approval. And next are the aviation bases here. So that's what the blue airplanes represent. And these are all aviation bases I've chosen where there have already been use of drones. So it's not just any aviation base, but they're usually Air Force, Navy, or Army airfields that where testing has already been done or is proposed, but mostly where testing and actual flights are already occurring with UAS. A lot of that you won't find in public data because it is for military purposes and it is classified a lot of the time. But thanks to this presentation by somebody in the Air Force, RPA is another terminology for remotely piloted aircraft. So that is a more international nomenclature for unmanned aircraft system. So if you ever see RPA or UAS, that just means drone. And for those who are lay people and don't care to respect the politically correct nomenclature of industry and military professionals who prefer to use RPA or UAS. Um, it's a big contention these days, and it's all about communicating information properly. And it's not about hiding the truth, but it's about communicating what these things really do. So there was some good data, like right here. This shows I got a lot of information here. A lot of this talks about what's going on. This is a really good presentation, giving a lot of good data. Let's see here. Here's one of the COA lists that came from EFF. Thanks to their efforts, this also helped me do some cross-referencing. Let's see what else we got here. This is the original Federal Register from 2012, showing the mandate from Congress saying that the FAA needs to pick 6 test ranges to integrate unmanned aircraft systems into the national airspace system. So this has been delayed because of privacy issues, and I think there's good reason for those privacy issues, and I think they need to be addressed. Unfortunately, the FAA normally doesn't deal with privacy. So if anybody out there who's concerned about their privacy and how the government's using drones, just know that the FAA really, they don't have the expertise to deal with privacy. That's usually the Supreme Court and groups like EFF. Other parts of the government, maybe perhaps Department of Justice, should be handling the issue of privacy instead of the FAA. But unfortunately, it falls on the FAA. Why? Because they have been tasked with this integration, and now it's being slowed down. So, moving on. Here's information from the RTCA. So this is the Special Committee 203, is the specific committee for unmanned aircraft systems integration. And you can see here, there are all these individuals from these different corporations. I use this to collect data and create my points. This is from their minutes from one of their meetings, and I use this data to kind of interpolate where manufacturers are coming from, and that's what these red wrenches represent. So if we look here at my list, and like I say, this is totally inaccurate for the most part because AAI, for example, is very involved with UAS development. And almost at any one of their locations, you might have some drone work going on. But when it comes to groups like companies like Boeing, okay, I collected a lot of Boeing sites here, and that doesn't mean that at every one of these sites there is UAS development. I put together a lot of Boeing sites because I wanted to use GIS to represent the possibility of economic investment, and that economic investment is important. And this is really important to understand. The FAA does not have a huge budget to invest in the integration. Neither does NASA. NASA is like advising the FAA and the community of stakeholders, okay, across the board. You could say that NASA is kind of way at the top, even above the FAA when it comes to standards and testing. It's because NASA has so much expertise, it has facilities, and it has the capacity to lead the way, let's say. But that's in concert with the FAA's mandate from Congress. And so, but they don't have a lot of money to do this. Where does the money come from? A lot of it's going to come from people like Boeing or Northrop Grumman or AeroVironment, General Atomics, obviously. So General Atomics is heavily involved in UAS because they have some of the iconic UAS like the Predator and the Reaper drones. Lockheed Martin, okay, Northrop Grumman, Raytheon is involved. Rockwell Collins, SAIC, Sierra Nevada Corporation, Sikorsky, SRC. So there's a lot of big corporations. A lot of them, some of them you probably never heard of if this is all new to you. But I collected a lot of data because, like I say, this collective economic powerhouse of corporate defense and aerospace assets could possibly be allocated to help in the development, the standards and integration of UAS in the national airspace, because most of these people are on this FAA list and they are seriously interested in making sure that uh, they can make money and profit from having UAS fly in the national airspace system safely. And it is the FAA's job specifically to make sure that it is done safely. So I have met with a representative from NASA who used to work for the FAA and who helps kind of bridge the gap between the two. I learned a lot about the process. His name is Chuck Johnson. He's at NASA out in Palmdale, and he's a very kind gentleman who allowed me to go out and interview him. I encourage you to look at some of the videos that I made of that interview. You can learn a lot about this process. Let's see here. We have university stakeholders also. So there's a lot of universities involved, and that's another dimension of this. And these groups, like say aviation bases, manufacturers, universities, this is all my way of separating these things. NASA, FAA sites, and Customs and Border Patrol. Realistically, Customs and Border Patrol is not the biggest stakeholder, but if anybody wants to know specifically, Customs and Border Patrol is the kind of one-stop shop for any federal use of UAS outside of Department of Defense. So meaning that like under the umbrella of Homeland Security, which covers any surveillance, law enforcement, search and rescue, for example, FEMA, the FBI, and even the National Guard have used UAS, the Predator and Reaper drones that are managed by Customs and Border Protection. So Customs and Border Protection, there's been a lot of criticism of their management of the drones that they have, and they're supposed to be service providers. So let's close out of Google Earth. You've seen what kind of how I collected this data now, and then I was able to take this and bring it into ArcMap by ESRI, but I'm using ArcScene now to kind of show you in 3D what this data looks like. So one of the things I did in GIS is I created buffers around the point data, and then I created corridors between different buffers, and then I created had to reclassify all of these into rasters. And if you don't know what that means, don't worry about it. But basically, I tried to create some type of symbolism that shows where are suitable places. So basically, these colors here that you see, the blue, the darker blue is less suitable, and green is more suitable. And don't get it mixed up with the green restricted airspace and the red Class B or aerodrome airspace. So, but they are associated with each other. And the bottom ground area here is the population data that comes, land scan data that comes from the Oak Ridge National Laboratories. And that has been reclassified also. It is not the original point data. This is actually a polygon that is transformed, converted the raster into a vector polygon. So it's kind of different. If I turn these off, you can kind of see this better. This represents population, and the red is a higher density population. So obviously, if you want drones to fly safely over the LA area here, for example, well, you're not going to test them here first. You're going to go out here to Edwards Air Force Base, where there's a lot of restricted airspace, as you can see here. And when I created, if I open this up over here, you can see these are cost distance, which are interpolated from or made from corridors. And what I've done is I've made these corridors between, for example, manufacturers and restricted airspace buffers, manufacturers and airbase buffers, manufacturer and NASA buffers, university and NASA buffers. So I created a matrix here between manufacturers, universities, and public stakeholders, and the either restricted airspace, the air bases, and NASA test sites. So that might look really complicated, and like I say, this is an art. This is something I created. This doesn't represent exactly how the test site selection process is going. This is perhaps a recommendation or suggestion or a starting point and a way to look at this and how to analyze this data. So if you turn it on then and back out here a little bit, the accumulation of the color green is going to be a more suitable area. And anywhere where there's a higher population, which you can see in here, is obviously not where you want to have testing going on. So where you can see up here towards Edwards Air Force Base, this is greener. This is a nicer area, a better area, perhaps more suitable for testing UAS. And also up here where China Lake is. And as a matter of fact, people in California have come together now. There was a competing test sites proposals for the Port Hueneme area down here and the China Lake area. And now I think there is a larger consortium that is suggesting that a whole corridor be created between here, Vandenberg, and Port Hueneme. And I would actually approve that myself, because there's a lot of open space through the mountains here and out into the ocean here. I think a lot of safe testing could be done here in California. Of course, that's my own bias, perhaps, because I'm from California and I live here. But anyways, there's a lot of other places in the United States where testing could be done. If we move over here, for example, there's a lot of testing already being done here in Utah. So let me try and show you the capabilities that I have here to show this more in 3D. This is ArcScene, which is basically a three-dimensional map. It's not exactly like the digital globe or that you would see in Google Earth or ArcGlobe. So Esri also has something similar to Google Earth or called ArcGlobe, and I could take this data and put it into ArcGlobe also, but I'm using ArcScene because I kind of like it better, and you could change a lot of the properties. So you can kind of see this three-dimension. The altitude of this restricted airspace is not accurate at all. I've just extruded the surface so that you can kind of see what a volume of airspace kind of looks like and how it's represented. It's not totally accurate at all. I'm gonna try to turn this a little bit more. There we go. Bring this up a bit. Let's see here, back out. So you have the Salt Lake area here. There's a lot of corporations and defense and aerospace people. You have Dugway Proving Grounds out here, and there's another old Air Force base out here, and this is all like Salt Lake, dry Salt Lake out here. And I think there's been chemical testing out here too. It's probably a very polluted area, maybe a perfect place to test UAS, right? But anyways, I wouldn't be surprised if this eventually becomes a test site, because there's already a lot of efforts going on here. Let me try to back out here. Having some trouble here. So let's start over again. And let's go to the East Coast here. I really didn't focus on Alaska or Hawaii, but they have made proposals now for test sites. And really, I think there's so many different variables to look into, and so many people are trying to grab onto this. So between New Jersey and down here in Virginia, Maryland area, there are a lot of ideal sites. Down here, there's a lot of testing that goes on at a naval air base. And although you see a lot of green around here, we have Washington, D.C. right here, and this is not actually an ideal area. So the thing that I haven't achieved yet in this GIS project is using a quantitative method, not just a visual method. My original goal was to use a database of information, to use a weighting scheme and add up the population data along with the restricted airspace. Oh, I need to turn that back on, I think. Or no, sorry, the Class B airspace. So here you see where there was a lot of green, you also see a lot of red, and the President of the United States flies out of here, and there's a lot of prohibited airspace around here too. So although there's a lot of industry you can see by these buildings, this is a university here. There's public interest here. There's air bases down here. I think down here at this Naval Air Station, Patuxent, I think it is pronounced. If I pronounce that wrong, please forgive me. Up here in New Jersey also, where the FAA has one of their aviation test sites. I think either one of these would be a great place. Perhaps if there was a corridor created between these two, testing could be done along here as it is being proposed in California. I think if you had two large test corridors, one on the East Coast and the West Coast, I could see these being created. Down in Florida, there's also a lot of opportunities around Cape Canaveral. As you can see down here, there's a lot going on. There's Redstone Arsenal, Marshall Space Center in Alabama. There's places in Georgia. There's places in Texas. Oh, and let me not anger the people of North Dakota, because we have the University of North Dakota and Grand Forks up here, and they are very involved and eager to be chosen as a test site. We also have Ohio and Indiana. University of Michigan has been doing some important testing, especially with UAS, smaller UAS that can land on the water, I believe. They've been doing important work over there. Texas, of course, wants to be a site. New Mexico has a lot of wonderful test space. You have White Sands test range. And let me not forget one of the places that I was stationed at when I was in the Army. We have down here Fort Huachuca. And Fort Huachuca is a perfect place for testing. They've already been testing. They do a lot of testing out here. This was electronic proving grounds. The Osprey that the Marines use has been tested out here. I remember seeing them testing that in the morning when I would go out to do PT. And there's a big group of people that want to sponsor this as a test site. So, am I forgetting anything here? This is from the EFF. This is one of the maps they created. So, thanks again to EFF for their work in trying to, communicate who is using UAS and who's involved with it, because I do believe that the public should know. I'm a proponent of using UAS, but I also think it should be done safely, and I think our privacy should be protected. So I think this concludes my presentation here. Oh, here's a little bit more data. For example, this is a FAA registration of actual aircraft, and you can go onto an FAA database and find this stuff. So you see General Atomics here. This is the actual aircraft with the registration numbers, serial number, manufacturer code, year it was manufactured, where they're located. So I've done quite a bit of research here. So if you've enjoyed this and you're watching this on YouTube, please subscribe and like this video, comment. I hope more people take a look at this. Sorry if this is long-winded, but you have to understand that this is not a simple case. This is the future of aviation. It's not just about flying robots. It's partly about performance-based navigation and trajectory-based navigation. It's about next generation, which are terms that come from the FAA, and the modernization of aviation across the board, not just in the United States, but across the world, because the International Civil Aviation Organization, which is sort of like the UN of aviation globally, they are actively involved in this integration process. So I've been to a conference down in Peru where ICAO and other Latin American organizations and countries got together to talk about this subject. And it was very educational. I met representatives from the FAA and people in industry who want to make money off of this stuff. So, that's part of the free market capitalist mentality, and that is what makes these things proliferate. And there's not much that we can do to stop it, but I believe that we should put some checks on it to make sure that it does not impede um, our lives, that it is to make sure that it is safe, that it doesn't endanger life and property, and that it doesn't impede upon our privacies. So thank you for watching.